So in the last lecture, we have discussed different types of HVAC system, its components, and several other things related to HVAC system. So in today's lecture, we'll learn about HEPA filter and clean room technology. So let's start. So this is a HEPA filter, you know, uh, we have air handling unit, and within the air handling unit, we have these HEPA filters. You can see that how these dust particles are getting filtered within this HEPA filter. This is pre-filter, this is HEPA filter, and this is VOG filter. So high efficiency particulate air able to filter particle size of 0.3 microns or larger than that. So its efficiency is 99.97%. That means if the return air contains 10,000 particles per feet cube, its construction would be reduced down to 3 particles per feet cube after it goes through the filters. You can see. So for being 99.97 effective, you have to within the 10,000 particle entering into this filter, only 3 or less than that should get out. So you can already see that uh, how efficient the filter is. The HEPA filter is disposable dry type filter in the rigid frame. It has the capacity of retaining particles as small as 0.3 micron with a minimum efficiency of 99.97%. The filter media consists of extremely fine glass fibers. So this is the filter media, the glass fibers. The medium glass fiber content is as high as 99%. Most of the microglass filter media on the market have fire retardant and waterproof properties. The superfine glass medium gives the HEPA filter distinctive filtration capabilities. It allows the retention of small particles due to the principle of Brownian diffusion, provides the interception by inertial effect of particles of intermediate size, provides a sieving effect of the large particle. We'll discuss all about that later during the mechanism. New generation ultra high efficiency filters are now available with 99.99% retention of particles at the zero point 0.1 micron level. So these are very efficient. So the current designation of those filters is ALPA, ultra retention particulate air filter, and another one is VEPA, that is very efficient particle air filters. So we need to learn about the difference between HEPA and ALPA filters. We can see here it's 99.97, but alpha is very efficient than those of HEPA filters, that is 99.999%. Particle size can filter particulate up to 0.3 micron or larger. It can filter particulate up to 0.12 micron or larger. You can see how sensitive it is. Here filter media is less denser. Here filter media is high denser. That is why alpha filter has is very costly also. Airflow is high. Here airflow is low. Power consumption is low, but in that case power consumption is high. Why high? Because it's filtering very efficiently. Filter lifetime is up to 10 years, but its filter lifetime is very lower than that. Why? Because it's filtering more efficiently. Okay. Filter cost low as compared to alpha filter, and in that case is very costly. So its application is seen in pharmaceutical industry mainly, and its application is in semiconductor industry. However, at present, this alpha filter is also used by some blockbuster pharma company. Now, let's discuss the classified area. Area having controlled airborne particle concentration is called as clean room or classified area. These areas are constructed to minimize the introduction, generation, and retention of airborne particles in the air. So ISO 5, 6, 7, 8, 9 clean room are classified area. We'll show in the next lectures. So what are the classified areas? Sampling area, dispensing area, granulation, blending, compression, coating, blister area. Because these are very critical or classified area or clean room area, because our product comes in direct contact with this area. Okay, that's why the airborne particles should be controlled in this area. However, there is some unclassified area also. Area having uncontrolled airborne particles concentration but controlled temperature and humidity is called unclassified clean room. Unclassified area are area in which product does not come in direct contact with air. This is the important thing. In the classified area, product was in contact with air, but in unclassified area, this is the opposite. So packing hall, BSR, raw material store, packing material store, change room, QC area. These are the example of unclassified area. So what are the key differences between these two? So in classified area, particle concentration are maintained, here not maintained. Temperature and humidity is maintained, here no maintenance. It come under ISO class, that is International Organization for Standardization class, but it doesn't come under this class. HEPA is used, HEPA filter is not used, and used for core production area, but it's not used for this production area. We can see here our clean room can be classified in 3 ways. Okay, according to the ISO guidelines, we have from ISO class 1, 2, 3, 4 up to class 9. Federal standard, this is the USA approved classification. In that case, we can classify class 10, class 100, class 1000, class 1 lakh area. And this is the UCGMP grade, that is ABCD. Okay. So what should be the maximum particle per cubic meter? Okay. In case of USA, this column is directly relevant to this column. Okay, class 100. Here is also class 100. Class 10,000. Here is also class 10,000. Means it should have 10,000 particles maximum in the room. We'll discuss very descriptively in the later slides. Here is the US Federal Standard classification. We have seen that 0.5 micron sized particles of measuring under feet cube. In case of class 100, we have seen maximum 100 particles can be present, which are having particle size of 0.5 or larger than that. In case of 1000, maximum 1000 particle can be retained in the area per feet cube volume of air, which have particle size of 0.5 micron or larger. So these are like that. Okay. So here definition has been seen that what do you mean by class 100? Class 100 is the area where the particle count must not exceed total of 100 particle, that is maximum 100 particle per feet cube. Okay, of having a size of 0.5 micron or larger. So in case of class 1 lakh area, what would be the definition? The definition would be that is the area where the particles count must not exceed a total of 1 lakh particles. That is the maximum of 1 lakh particles should be there. So what would be the size? The size of the particle would be 0.5 micron or larger. Okay, so you have to learn up to that. You don't need that, the remaining part. So as a general rule, the tableting facilities have clean room for class 1 lakh. Topical and oral liquids have 10,000 area. Then injectables, which are very critical, are having class 100 area. Now we'll discuss European Committee guidelines for clean room, that is which are classified as A, B, C, D. So it has been classified into two different conditions, actually at rest and in operation. So what do you mean by at rest? So at rest means state of clean room in the condition where the production equipment is installed and operating, but without any operating personnel. That means here no personnel should be present, but operation may be continuing. Okay, but this condition should not have any personnel. Okay, there should not have any personnel. But in case of operation, in operation, what is happening? State of clean rooms in the condition where the installation is functioning in the defined operating mode with the specified number of personnel. So here no personnel, here personnel would work. This is the main difference. But operation would be ongoing in both of the cases. So maximum of the students make the mistakes here. What mistakes? They thought that at rest condition there would be no operation. No, this is not correct. At rest, operation is going on. The drying, mixing, blowing, filling, sealing, granulation, all is conducting here. But no personnel is present at rest. So we have already seen the classification by European Economy Guideline, that is ABCD, particles at rest and that is in operation. You can easily understand that during operation, as personnel are present, the particles count would be more. Okay, you see that is 35,000, but in case of operation, it is 3.5 lakh, more higher, 10 times higher. Okay, so this is the overall case. The particle size is count on based of 0.5 micron particle. We have already seen the classification, European Community Guidelines. The grade A areas include different filling zone or stopper bowls or open ampoules or vials or aseptic condition by sterile area. Typical application of example of grade B areas are aseptic preparation and filling area, aseptic receiving area, aseptic changing room, solution preparation room, etc. And grade C and D area are solid dosage form area or warehouse area. So this is the main connection between European and American classification. That is class 100 means A and B, class 10,000 means grade C, and 1 lakh means grade D. So one question may arise, why only 0.5 micron and 5 micron particles count down for clean room? This is very crucial question. So why only 0.5? Why not other size like 0.1 micron or 0.3 micron or 10 micron? Why not those particle size? So why only 0.5? So we'll learn about that. The main reasons are most commonly bacteria range is in between 0.5 to 5 micron. So this range of particles are a main source of product contamination because in our air the most commonly found microorganism or airborne particle is bacteria. The size of particles less than 0.5 micron are not so critical because microbes are less likely to attach to these particles. Particles having size larger than 5 micron become heavy as size of these particles increases and settle down as compared to 0.5 and 5 micron particles. So we have already understood that the clean room area uh, controls the temperature, pressure, and airborne particle very critically. So how pressure is controlled? There should be a net airflow from aseptic room to the non-aseptic area. Why? Because if air comes into the aseptic room, then it would ultimately leads to the contamination in aseptic room. This is possible only if there is a pressure gradient between two adjacent rooms. Air always flow from high pressure to low pressure region. Pressure difference between two rooms is differential pressure. So always the aseptic room condition, the aseptic room should have positive pressure. We should keep in mind. So tableting facilities, 1 lakh area, injectables are class 100 area. We have shown this earlier. So air change per hour. We know that sterilized area should have higher air change than those of non-sterilized area. So USP, that is United States and European Economic Community has already said their limitation. So how air is filtered? First of all, fresh air is taken, then pre-filtration is conducted, then temperature adjustment is done, then humidification is performed. Finally, the air comes into the HEPA filter. So the steps has been shown here. So now we will learn about the mechanism of air filtration. There are four basic mechanisms of air filtration based on their particle size. So for these are inertial impaction, direct impaction, electrostatic force, diffusion. The larger particles are usually have these two mechanisms, whereas the smaller particles undergo Brownian diffusion, and the electrostatic force is applicable for the charged particles. So this is the overall scenario. In case of larger particle, these get stuck or directly intercept into the fiber of the filter media. The larger particle is also having inertial impaction. Because of its inertia, particles are attached to the fiber. In case of smaller particle, it has some Brownian diffusion and get stuck into the fiber. And in case of electrostatic effect, sometimes due to the movement of particles, some charged may be appeared, and the electrostatic effect can ultimately enhance the attraction of the charged particle with the nanofiber. So let's see a video here. Uh, Watch this very carefully. We can see how air is filtered. The blue one is airflow pattern. Okay, this is the airflow. These are the particles. We can see the larger particles cannot move outside there. That's why they get stuck into the glass fibers. The medium-sized particles are going through this way, but they get stuck by direct interception. The heavier particles are stucking into this by direct interception or inertial impaction. But in case of smaller particle, we can see these are coming as Brownian diffusion. Okay, so these are all from the HEPA filter mechanism. So inertial impaction, this effect is more evident on particle size larger than 1 micron. So heavy particles or very large particles are having this mechanism. When the air flows and encounters randomly oriented obstacles, particles traveling in the airstream must change direction if they are to follow the stream. Because of inertial forces, this cannot happen quickly enough and the particles impact a fiber in the filter matrix. The effectiveness of the inertial impaction is increased by increasing the velocity of the airstream. Our next one is direct interception. The particles of negligible mass, that is 0.5 to 1 micron, these are smaller than those of inertial impactions, are likely to trapped not only by inertial impaction but also by direct interception. This method works for 0.5 to 1. Then electrostatic force. As the name suggests, this is applicable for the charged particles. The last one is diffusion, that is Brownian diffusion mechanism. These particles are having very smaller particle size, like 0.2 to 0.3 micron. These are undergoing Brownian diffusion, and as the particle moves in the disorganized motion, they are trapped by the randomly oriented microfibers at the that constitute the filter. However, after designing of the HVAC system, we need to validate this whether it is working properly. That's why several validation tests are conducted for maintaining HVAC system, like airflow pattern test, airflow velocity test, which is called also ACPH, filter leak test, particle count test, viable monitoring test, then filter integrity test, that is DUP test, differential pressure test, recovery test, temperature and humidity uniformity test, pressure determination test. We will learn about smoke test. Okay, so smoke test is done for visualize the airflow pattern in sterile cleanroom area. Smoke flows according to the flow of air in the area and shows its path. Titanium tetrachloride powder used as a smoke in smoke test, used in pharmaceutical, food and electronic industries. So let's see how smoke test is done. We can see smoke has been used in the duct line, and this is unidirectional airflow of HEPA filter. The air is flowing very efficiently and getting up by the drainage. Okay, we can see the pattern or unidirectional airflow here. That is HEPA filter is working properly. Objectives of smoke test: to observe the airflow pattern of clean room, whether it is unidirectional or non-unidirectional. To confirm unidirectional airflow of air coming from HEPA filter. Smoke test demonstrate the movement of particle in clean room. So how this test is performed: start the smoke generator and keep the generator probe in the front of HEPA filter and record the airflow pattern by video recording. So the advantage is it is very easy to perform due to long last dense smoke and portable machine. And disadvantages is difficult to capture airflow pattern of large areas because of HEPA dissipates quickly. So we have already understood that there are two types of airflow. One is unidirectional, that is air is uh, flowing in one direction, and another is non-unidirectional, that is air is traveling haphazardly. Okay, so let's see. First one is non-unidirectional. You can see that air is flow is not uniform. This is going there, this is again coming upward, going below, coming upward, some air is going here. Non-unidirectional. Air flow pattern is turbulent. Supply diffuser generate turbulence in air, can maintain cleanliness level up to 10,000 to 1 lakh area. This is usually used for warehouse area or QC area like that, where air control is not necessary. And another one is unidirectional airflow. This is required for clean room technology. It is also called laminar airflow. In our pharmaceutical microbiology lab, we have already used this laminar air hood, and we have seen the parallel streams are maintained within 18-degree to 20-degree deviation. So velocity is maintained at 90 feet per minute. Okay, this guidelines has been set by US federal standard. So this is important for class 100 area, like parenteral areas. However, as we are discussing about clean room, there is a difference between normal clean room, normal HVAC system and clean room HVAC system. We can already understand that normal HVAC is not so much efficient as those of clean room HVAC. Okay, so clean room HVAC is used for classified area. Normal HVAC is used for non-classified area. So air supply, you can see that air changes per hour is higher in clean room, 50 to 100. But in case of normal, it is 2 to 10 air changes per hour. So here HEPA filter is used, which is very efficient, and here we can see low efficiency filter is used. Airflow pattern is laminar or unidirectional, but in normal HVAC, it's not necessary to use unidirectional. Room pressure is positive in clean room area. Okay, but it should not necessary to always keep positive pressure in this area. So after the preparation, maintenance, validation of HVAC system, we have to document this. Okay, documentation means whatever the design, operation, and performance of the HVAC system, we have to document this in a particular format. So the design qualification should cover following information: identification of various systems, their functions, schematic and flow diagrams, sensor, damper valves, etc., critical parameters, fail safe positions, layout plan showing various rooms and spaces and critical parameter, room temperature, humidity, room pressure, process equipment, location, critical instrument, recorder, alarm, equipment performance and acceptance criteria for fan, filter, cooling coil, heating coil, duct and pipe layout showing air inlet, outlet, air quantities, water flow pressure, control schematic, control procedure. So these are all from our HVAC system. If you have any confusion regarding this chapter, please let me know in the comment section. Thank you.